let's get good at C++. Firstly, you would want to open up CMD. I'm assuming that you have some sort of way to write C++. I recommend dev C++ Bloodshed. I believe it's called Embarcadero now. Let me go find it. Ah yes, Embarcadero dev C++. So this is a pretty good way to like get started already. For those of you who already have an environment to write it on, then hey, why not, right? Just get started. I also think there should be a few online platforms. Like for me, in the majority of my career starting C++, I used REPL it, but I believe now you only get 3 free REPLs, so yeah, find a solution that works for you. I believe CLion is also good, though I'm not exactly sure if, yes, you can use C++ on it. So yeah, that aside, let's kind of get into the very basics of what a C++ program will look like. So without further ado, let's just get right into it. Alright, so when you want to create a C++ program, I mean, I guess I'm on Linux, so I'll be using Nano. So you would just use a .cpp extension. So if I want to try hello.cpp, then bam, oh my god, I already have a file called hello.cpp. Okay, wait, you know what? I did not know I already had a file called hello.cpp, so let me try something else. Nano, I don't know, new.cpp. Great, amazing. You will be brought to kind of empty nothingness. So how exactly would we start with this empty nothingness that we have here? Well, firstly, you need to do this thing called declaring a library. So what exactly is a library? Well, you can think of a library as a physical library. Right now, you have an amount of knowledge in your head, but if I wanted you to become an expert in architecture, which you know nothing about, you would want to go to the nearest library, take a book, maybe read some stuff there, come back, and then you'd be an expert on it. And that's kind of how libraries work with programs. Because your code right now, all of your C++ stuff on your computer, does not exactly know how to do certain things. So by including a library, it now has access to that knowledge of how to do certain things. So, for example, if we wanted to use functions like cin and cout, regular C++ doesn't exactly know what to do with those. It doesn't understand what cin and cout mean. But by including a library at the top, then it knows, because it can kind of grab the info from that library and use it where necessary. So how do you go about including a library? Well, it's hashtag include, and then in these funny bracket thingies, iostream. So this basically talks about getting the info from the iostream library so that you can use certain functions. And the kind of main purpose of this is so we can use cin and cout, which I'm about to show you. After this, we have to write this line called using namespace std. So this is basically declaring your namespace used in all of the preceding lines as the standard namespace. Later on, I can show you why you would have to write this line. It's because if you don't write this line, you would have to write std : in front of all of the stuff that you write. And that is kind of annoying. So for a very base level, while we're still figuring out the reins and the controls of how to navigate this crazy world, let's stick to just writing this for now. Beyond this, where does our actual code go? Well, if you're familiar with most programming languages like Python, you might think the code just kind of goes here. But no, that's not right, because C++ kind of doesn't know. When you actually run your program, right, you will be calling the main function. Your compiler kind of calls the main function. So we need to put everything that we have that we want to execute inside of main. And the way that you create your main function is through int main. For now, we'll just be using int main, but yeah. Later on, I'll probably explore different functions and kind of introduce you to how you can get these to work. But for now, int main, and inside of all of this is where you put your code. So yeah, your code. Now we get to the slightly more difficult part. How do you write code? Well, before I get into how to write code, let's talk about how not to write code, which is a comment. So comments are basically like lines of text that don't do anything. When the code is run, your computer just ignores these lines because there is nothing there. It just takes it as, okay, the developer left a sticky note for himself or like a self-reminder or something. This isn't actual code that we have to read. And you do it by putting 2 slashes down and then you write whatever you want. This is just a reference so that when I start writing actual code and I start putting down comments, at least you kind of understand what I'm saying. Okay, so firstly, let's do a cout, which just kind of prints something. A cout is just cout followed by 2 arrows to the left. We'll later come across another function called cin, which is 2 arrows to the right. And I have this very weird way of remembering it, which is kind of like juggling, because you take something with your right hand, pass it to your left, and throw it out with your left. But again, it's kind of up to you how you want to try and remember this. Yeah, but cout is to the left. And after that, inside of 2 double inverted commas, you can write whatever you want. So for example, hello. This itself is a string. A string is a data type, which we'll cover later. It is just kind of a piece of information that the computer can deal with. And you might be wondering, isn't something missing? Well, something is missing, and that is your semicolon. Your semicolon has to be placed at the end of any kind of line of code that isn't like a statement or like a condition or like a loop, something like that. If it's just do a thing, like a thing you want your computer to perform, you need to put a semicolon at the end of it. That is also why we did it here. But for now, you just take these first 2 lines as just do it, and then later on we'll get into I guess slightly more interesting ways of applying the first 2 lines. Okay, so now that we've written our very basic code, let's kind of X out of this and see what this does. So if I save this and I X out of this, then I will use G++, which is a compiler that I'm using. So if I put G++, right, new.cpp, which is telling you, okay, compile this and put the output in this thing called new, right, and then you /new, congrats, it prints out hello. This is the output of your C++ file. Well, depending on what you use, this output will be reflected in a different place. I'm using a terminal, so it's reflected here itself. But if you are using a code editor, like for example VS, CLion, or Dev C++, then there might be a terminal window within your software that you have to look at to see what the output is. For me, however, I would say it's slightly easier. It's kind of right here and it's good. So yeah, we got our first C++ done, and that's quite an accomplishment. Great job. You're already better than most people when it comes to programming. No, you're not, but it's okay, we'll get there. So then let's kind of look at what else we can do with iostream. So if we nano and get back to our code, you'll notice I did talk about something called cin. So what exactly does cin do? Well, cin allows you to input into something. But what is that something? Okay, now let me introduce you to the glorious world of variables. So variables are a box. You can think about it. A variable is a box that you can put a piece of information into. Now, what exactly do I mean by that? Now, let's say that I have a box. Oh, it's been a while since I've used this. Imagine I have a box, right, that is able to store numbers inside, right? And this box is called box 1. I can take a number like 9 and put it inside of box 1. And anytime I want to find out what's in box 1, I can take out the value and it'll tell me it's 9. So you can use boxes as a way to, variables as a way to kind of hold information. So let's say I have a box and I put the number 9 inside, take it out, and then put the number 5 inside, take it out, and then put the number 4 inside, and I repeat this process for like 1,000,000 times. This variable will be able to tell me what the final end thing is without me having to go think, 5 did go inside, and then 9, and then 4, and then recalling every single thing. So a variable just allows you to kind of store information and deal with the information and retrieve it whenever you want. So in most programming languages, variables require a type. A type you can think of is kind of like the shape of the box. So ignoring that one viral video about the lady who got pissed off by someone who kept putting everything in the square hole, right? Most things fit in boxes of the kind that they are. Wow, that was a mouthful. What exactly do I mean by that? Let's say that we have the number 9 again. We can put it inside of a box, right? That is meant for integers. But if I had the letter A, you can't put that into a box meant for integers. Does that make sense? That's kind of what type is. You can't just take a random thing and put it into a box that can't accept it. So, if we have a box that's designed for integers, you can't take a character or a string or anything of weird sort and put it in there. So, let's deal with integers to keep our life simple for now. Let's say we want to create a variable. All we need to do is write int and then whatever variable we want to call it. For example, my variable equals 0. This is a way that you can declare, hey, I have created a variable, and when you start creating the variable, immediately put the value 0 inside. Then you can kind of change the variable. You can say my variable equals 1. And if you do that, right, and you see out my variable, what are you gonna get? Well, let's run it and find out. You will get 1. And the reason for this, as we can kind of see from our code, is that when you have your variable and assign the value 0 to it, and then reassign 1 to it, it's like the example I quoted earlier, where you take a box, put the number 9 inside, and then put the number 5 instead by taking out the 9 and putting 5. So this is kind of what you're doing. By restating, you are kind of telling the computer, okay, change the value of this real quick. So yeah, and you may be wondering, so can I just kind of change the equality? Can I just put 1 is equal to my variable? Well, you can't. That's because whatever on the left is assigned to whatever's on the right. Which means if you say my variable equals 0, you're saying the number 0, put it inside my variable. But you can't put my variable inside of a number, like a mathematical constant. You can't do that. So you can't write 1 is equal to my variable the same way you can write my variable is equal to 1. And yes, here is a way that I just showed you. You can kind of check on your variable or print it out so you can immediately tell what value it is, as just now it showed 1. So in this case, you can manipulate variables and output them, and that's kind of how programming works in a very basic level. So back to like cin. What exactly does cin do? Well, cin allows you to take values and put them inside of variables. Fun fact, you don't actually need to put equals 0 there. You can just do this and the computer will automatically assign 0 to it, while you can kind of not tell it to. So if we just say int my variable, that's like telling the computer, okay, create this variable called my variable and leave it at that. And then if you put cin and to the right 2 arrows, and then you put my variable, then you are effectively telling the computer, take in the value that's typed into the terminal and store it into my variable. And the next line says, take the value from my variable and throw it back out onto the terminal. So, let's see this run in action. Well, if I X out of this, and I compile again, and run again. Oh wait, why is nothing happening? Why is it waiting for me? I don't understand. Why is it kind of waiting? Well, it is waiting for you to type something, because that's what cin does. It waits for you to give it an input, for example, like 9, and then it'll return that input to you as a cout. So in this case, you input 9, the computer stored it in my variable, then it took it out of my variable and showed it to the terminal, which is exactly what our program did. Great, awesome. You managed to get a very basic input-output C++ code done. Now, can we customize this a tiny bit? Well, let's say instead of cout my variable, we had something that cout a phrase and then my variable. Well, you can do this just by adding 2 more. And then inside of these inverted commas, you write, for example, you entered, and this. If I save this, what do you think is going to happen? Well, logically, you declare a variable, input into the variable, and before you output, you say you entered. So the output value should be you entered and then the variable, right? Let's see if it happens. Well, it's waiting. I'll put, for example, 13. And you entered 13. That's amazing. Okay, great. It all worked out. So yeah, now you understand how I/O works and how you can kind of mess with the output and see what things you can do. Well, you can actually bring this a step further. So another data type I want to introduce to you is something called a string. A string is a literal, which means the computer will take anything as a string value. A string you can think of like a sentence, or a username, or even a password. It is any combination of capital letters, lowercase letters, numbers, symbols, even foreign characters sometimes. And all the computer does is it just takes it as at face value and lets you input or output with it as you please. So in this case, let me just shorten this string to name. Oh, whoops. I keep forgetting there is a delete key. So yeah, if you do this, right, then instead of just having to deal with the numbers, you can now deal with other things, like, for example, if I put drngd, you enter drngd. Well, if you try doing that with an integer, it would almost always give you an error if it was a string, or something weird would happen, depending on your programming language. But in this case, since you are dealing with a string, the computer is willing to accept absolutely anything you throw at it. So, let's kind of customize this a bit. String name, cin name, and then you entered, right? How about we make this a bit more welcoming? We say cout, and over here we write, what is your name? Question mark. And again, you have to cin, and then instead of putting you entered, you can write your name is this. Logically, what do you think this does? It declares a variable called name, you output what is your name, and then you take in whatever the user inputs, and then you output that after your name is. Well, let's try running it. What is your name? My name is random example Leo, right? Your name is Leo. That's exactly what it does, which is amazing. It's awesome. It's great. Now, let's take another look at this. How else can we kind of make this better? Well, you might notice, right, that the formatting is a bit weird, because after it asks what your name is, it doesn't leave a line, and after you enter, it doesn't leave a line again. So how do we deal with that to make it look cleaner? Well, there's this thing called an end line that I'd like to introduce you to. So an end line kind of tells the computer to just leave a line. It's that simple. All you need to do is put these two left-facing arrows and then just put end L. And you can do that after this one as well, end L. So if you do this and you save it, and then you X out of it, you run it, what is your name? And you see it immediately leaves a line, so you don't have to type on the same line as the prompt was given. So in this case, if I put, for example, my name is Eminem, and I enter again, it'll leave another line and then give me your name is Eminem. And then if I had any more output after the your name is line, it would leave another line to go to that output. So that's part 1 done.